Hello and welcome to the final segment in our series celebrating Mastertech's 50th anniversary. We hope that you found these segments about Mastertech history and the changes that have occurred in the automotive service industry enjoyable and informative.
Say, you weren't going to close out the 50th without me, were you?
I knew something was missing. What do you think we ought to do this time, Tech?
Well, if you'll remember, we started off the year with some comments from Chrysler's chairman. So why don't we close out the year the same way?
Well, sounds like a winner to me. And it just so happens that Mr. Eaton had something to say about Mastertech at the dealer announcement show this year.
Hello to all of you. These days, Chrysler and its dealers are enjoying a lot of well-deserved success in the marketplace. It begins with providing truly exceptional vehicles to delight our customers. But it doesn't end there. Service is a vital role in keeping our customers delighted, and knowledgeable, well-trained technicians are crucial to providing world-class service. As vehicles become more complex, they require more sophisticated service. It's not a job for a shade tree mechanic. Today's service technicians must be expert in a number of disciplines: mechanics, hydraulics, electronics, and even computers. It's important to give them the information they need to accomplish their mission. That's why I'd like to give a special salute to the Mastertech program. This year, it marks half a century of providing quality service information and training to our technicians. That makes it the longest running program of its kind in our industry. For 50 years, Mastertech has been invaluable in helping technicians stay up to date on changes in service procedures and vehicle technology. And it's played an important role in building our reputation for service excellence. Mastertech is a great program, and we deeply appreciate the contribution it has made to Chrysler's success. I'm sure that Mastertech will continue to be an important resource in our service operation for its next 50 years. Thanks again.
After your brief introduction to the new 2.7, 3.2, and 3.5-liter engines in the October program, you may be a little apprehensive about working on them. Well, you shouldn't be. The 3.2 and 3.5-liter engines are based on the 3.5-liter engine used previously. The 2.7-liter engine, although it is all new, is also really not difficult to work on. However, when working on any of these engines, having the correct information and the proper tools can make all the difference. In this month's Mastertech, we're going to help provide you with that information by first looking at the general features of both engines and similar lower-end features. Then we'll look at lower and front-end features of the 2.7-liter engine in particular, including primary timing chain removal and installation. After looking at 2.7-liter engine upper-end features, we'll go on to discuss features of the 3.2-liter and 3.5-liter engines. This month's reference book contains additional information about engine availability and general engine specifications, so be sure to refer to it. The 2.7, 3.2, and 3.5-liter engines have a number of common features. Like the engines they replace, the new engines all have a north-south orientation in the engine compartment. Unlike previous engines, all the new engines use an aluminum block with cast iron cylinder liners. Although all of the engines use overhead cams, the 2.7-liter engine uses separate cams to actuate the intake and exhaust valves in each cylinder bank, while the 3.2 and 3.5-liter engines use a single cam for each cylinder bank. It's important to keep in mind that none of these engines is freewheeling, and that proper valve timing is critical to avoid valve-to-piston contact. The new engines have similar cooling system features, which are different from the features on the previous engines. The thermostat on the 2.7-liter engine and that used on the 3.2 and 3.5-liter engines are located at the block's coolant inlet instead of the outlet as on previous engines. Because of this, both thermostats are designed to open at 180 degrees instead of the higher temperatures used with outlet-side thermostats. Another cooling system feature is the use of a coolant pressure and recovery bottle. This two-chamber bottle has a pressure side and an overflow chamber to allow coolant recovery. You'll notice that the recovery chamber is usually empty during normal operation. On the fuel and ignition side, you'll notice that all of the engines use single throttle bodies. All of the engines also use a coil-on-plug ignition system, in which each spark plug has an individual coil directly above it. You'll learn more about this new ignition system in a future Mastertech program. In October's Mastertech, you learn that the 2.7-liter engine uses spark plugs with tapered seats, while the plugs on the 3.2 and 3.5-liter engines use gaskets. With both these plugs, torque is critical during spark plug installation, so be sure to refer to the service manual for the spark plug tightening procedure and for torque specifications. Now let's turn our attention to some similar lower-end features of the 2.7, 3.2, and 3.5-liter engines. To minimize flexing, all of the engines have a structural collar that is bolted to the oil pan and transmission. To avoid damaging this collar or the oil pan during collar installation, it's important to use the tightening sequence detailed in the service manual. A structural oil pan and windage tray also increase stiffness on all three engines. The edge-molded rubber gaskets for the oil pan and for other engine components have a metal backbone, which provides superior sealing by precisely controlling gasket compression. As a result, there is less of a gap between components, and fasteners maintain their torque better. The new gaskets minimize the need for sealant at mating surfaces. On the 2.7-liter engine, you need to apply Mopar silicone rubber adhesive sealant at only 2 spots, where the oil pan gasket and timing cover gasket meet. On the 3.2 and 3.5, you'll need to apply sealant where the oil pan meets the block and oil pump housing in the front, and where the pan meets the block and rear seal retainer at the back of the engine. All of the engines support the crankshaft with 4 main bearings, with 6 bolts for each main bearing cap. The main bearings are numbered from the front of the engine to the back. All engines use loose thrust washers, which are installed in the block after crankshaft installation. On the 2.7-liter engine, they are installed on the number 3 main bearing. On the 3.2 and 3.5-liter engines, the thrust washers are located at the number 2 main bearing. To determine which main bearing inserts are used on a particular main bearing journal, you'll need to become familiar with the main bearing select fit procedure. The procedure involves using the numbers on the lower edge of the block near the oil pan mating surface, and numbers and letters on the rearmost crankshaft counterweight. Numbers ranging from 1 to 3 are used on the 2.7-liter engine, while the 3.2 and 3.5-liter engines use the letters A, B, and C. Comparing these numbers to those in the chart in the service manual enables you to determine which of 5 main bearing sizes is used on a particular main bearing. For example, suppose the number for the number 1 bearing is 2 on the block and 2 on the crankshaft counterweight. In that case, the main bearing grade is the standard size. The main bearing grade is also marked on the new bearing inserts to facilitate replacement. Another similarity in the lower end of these engines is that the oil pump is driven by the front end of the crankshaft, and that you can access the oil pump relief valve after removing the oil pan. Next, we're going to look at some features of the 2.7-liter engine. But before we do, try this review question. On the 2.7-liter engine, the thrust washers are located at which main bearing? A, 1, B, 2, C, 3, or D, 4? The answer is C, 3. The thrust washers are located at the number 2 main bearing on the 3.2 and 3.5-liter engines. At this point, let's take a look at some specific features on the lower and front end of the 2.7-liter engine. When installing the rear main oil seal retainer, use special tool 8225 to make sure the retainer is aligned properly. Later on, we'll see how you can use the opposite side of this same tool on 3.2 and 3.5 liter engines. The 2.7 liter engine piston and connecting rod assemblies also have some features which you should be aware of during service. An F above the piston pin boss and an arrow on top of the piston must be toward the front of the engine during installation. The oil squirt hole on the connecting rod must face the major thrust side of the block. To determine the major thrust side of the 2.7 and other V-block engines that rotate clockwise, use the left-hand rule. Standing at the back of the engine, point the forefinger of your left hand toward the front and point your thumb up to indicate the top of the engine. Your middle finger points towards the right, which indicates the major thrust side. Together with the piston orientation markings, knowing the correct squirt hole orientation can be helpful in determining whether the piston is correctly assembled to the connecting rod. On the 2.7, 3.2, and 3.5 liter engines, this should not be much of a concern, since the piston and connecting rod are replaced as an assembly. On 2.7 liter engine pistons, notice that the connecting rod was fractured during manufacturing to form the connecting rod cap. The connecting rod cap bolts are captive fasteners, but since the bolts should only be torqued a limited number of times, they can be removed and replaced. To avoid damaging the cylinder bore, the crankshaft journal, or the cap itself, use special tool guide studs 8189 when removing and installing the pistons. As always, with a fractured rod cap, it's important to make sure you mark the cap so you can install it in the original position. Do not mark the caps by stamping them. Use a marker or paint to avoid damaging them. The front end of the 2.7 liter engine also has a number of unique features that you'll need to be aware of during service. In an earlier Mastertech program, we told you about the new AC drive belt tensioner. You may recall that the tensioner has one position you use when installing a new belt and another position when you're installing a belt that has been on the vehicle for 500 miles. The reason for the two positions is that the new belt position has to allow for belt stretch, and the used belt position does not. Keep in mind that you'll need to remove the tensioner to change positions. If you do need to remove the tensioner, be sure to maintain tension on the spring when removing the locking bolt to prevent the sudden release of spring tension. To service some of the front end components, you'll need to remove the crankshaft damper using several special tools. Use special tool 8191 to hold the damper when removing the crank damper bolt. You should have received this holder either in the Prowler or in the LH special tool kit. Use puller 1023 and insert 8194 to remove the damper from the crankshaft. And when installing the damper, use special tools 8179 and 6792-1. The timing cover on the 2.7 liter engine uses one of the edge-molded rubber gaskets we mentioned earlier. You'll need to use a bead of Mopar silicone rubber adhesive sealant at the joint where the timing cover and oil pan gaskets meet. The water pump on the 2.7 liter engine mounts directly to the cylinder block and is driven by the back side of the primary timing chain. This mounting places the pump in an oil-lubricated area and makes venting the ordinary seepage past seals more important than ever. Two passages in the block allow the water pump of the 2.7 liter engine to vent. One is a weep hole near the thermostat housing. A small amount of seepage at this hole is normal. However, a large amount indicates a water pump seal leak. The other passage is located in the valley of the engine block. As mentioned in the October Mastertech program, the thermostat used on the 2.7 liter engine is a dual poppet design. As the main poppet opens to allow coolant to flow into the block, the inner poppet closes off the coolant bypass. One of the special features of the 2.7 liter engine is the use of chains to turn the intake and exhaust cams and the water pump. The primary chain is driven by the crankshaft, and as mentioned earlier, the back side of this chain turns the water pump. The front side of the primary chain turns the intake cams. The chain is lubricated by oil that spills out of the oil pump. 3 fixed guides keep the primary chain in place. There is also one pivoting tensioner arm that is held against the chain by the primary tensioner. The primary tensioner uses engine oil pressure to maintain pressure against the tensioner arm. However, there is also an internal ratcheting device to limit chain slack at startup before oil pressure develops. A wear indicator groove on the tensioner is normally hidden by the tensioner housing. However, as wear occurs in the chain drive system, the plunger extends farther out of the housing and the groove can be seen. This indicates the need to replace the timing chain and inspect other timing drive components. When checking to see if the groove is visible, be sure to rotate the crankshaft to provide the tensioner side of the chain with slack. This allows the tensioner to extend fully. Later on, when we look at primary timing chain removal and installation, we'll cover resetting the tensioner. Besides the primary timing chain sprockets, the intake cams have some other components on the front end. The right intake camshaft contains a damper which must be installed on the cam to reduce vibration in the chain drive. The left intake camshaft has the slotted ring used to produce the camshaft position sensor signal. In each cylinder head, a secondary chain, driven by the intake cam, turns the exhaust cam. These chains each have a secondary tensioner that, like the primary tensioner, uses engine oil pressure. Whenever these tensioners are removed from the cylinder head, they need to be reset and locked in position prior to installation. Tensioners on early build engines can be disassembled, drained of oil, and compressed by hand until the locking pin can be inserted. Later build engines use a tensioner which cannot be disassembled, so you'll have to place the tensioner in a vise and slowly compress it until you can insert the pin. Timing marks on the 2.7-liter engine timing chain system allow you to check crankshaft to camshaft timing and service components without damaging the engine. When the crankshaft sprocket timing mark is aligned with the mark on the oil pump housing, the number 1 piston is at 60 degrees after top dead center, and the pistons are positioned so the valves cannot contact them. The intake camshaft marks are located on the sprockets, and as we'll see later, are designed to align with plated links when the chain is installed on the engine. The exhaust camshaft marks are also located on the cam sprockets. The camshaft marks can be used to verify engine timing. To do this, place the number 1 cylinder at top dead center on the exhaust stroke. At this point, the timing marks on the intake cam's secondary timing chain sprockets should be 90 degrees from the cylinder head cover sealing surfaces. The marks on the exhaust cam sprockets should be 12 pins away from the marks on the intake camshaft sprockets. We'll see more of the timing marks in our next segment concerning primary timing chain removal and installation. But before we move on, try this review question. The special tool shown here is used to A. Align the oil seal retainer, B. Install the pistons, C. Hold the crankshaft damper, or D. Reset the secondary tensioner. The correct answer is C. Special tool 8191 is used to hold the crankshaft damper when removing the damper bolt. Because the 2.7-liter engine's valve timing system is different from what you've seen in the past, we're going to cover the primary timing chain removal and installation in this program. Of course, to get to the primary chain, you'll first need to remove several engine components. Next, align the timing marks on the crankshaft sprocket and oil pump housing. As mentioned earlier, this positions the pistons so they cannot contact the valves. After removing the primary chain tensioner from the right cylinder head, remove the camshaft position sensor from the left cylinder head. At this point, remove the chain guide access plug from the left cylinder head so that later on you can remove the upper fastener from the long chain guide on the left side. Next, remove the right camshaft sprocket attaching bolts. The cam may rotate when the fasteners are removed. Remove the damper and the sprocket. Then remove the left cam sprocket attaching bolts. and remove the sprocket. Next, remove the long chain guide on the left side and remove the chain tensioner arm. Now you can remove the primary chain from the engine. After inspecting the primary chain drive components and replacing any that are worn, you can begin the installation procedure. First, make sure the timing marks on the crankshaft and oil pump housing have not moved. Next, position the chain on the left primary chain sprocket so the camshaft timing mark is between the two plated links. Lower the chain and the left sprocket into the opening in the left cylinder head and place the sprocket on the camshaft hub. Position the chain on the crankshaft sprocket so that the plated link on the chain aligns with the timing mark on the sprocket. Next, place the opposite side of the chain on the water pump sprocket. Then position the chain on the right primary chain sprocket so that the plated link on the chain aligns with the mark on the sprocket. And place the sprocket on the right intake camshaft hub. Before proceeding further, make sure all of the timing marks are aligned properly. Next, install the long chain guide on the left side and the tensioner arm. You can now install the chain guide access plug in the left cylinder head. If you've installed the components correctly, the slack in the chain should be on the tensioner side. At this point, you need to reset the primary chain tensioner so it can be reinstalled. To do this, first, separate the tensioner from its housing and drain it of oil by slowly pressing the check ball end against the shallow side of Special Tool 8186. After placing the tensioner back in its housing, you need to reset the tensioner by positioning it in the deeper side of Special Tool 8186 and pressing downward until you reset the tensioner. Once the tensioner is reset, you can install it into the right cylinder head. Next, align the right camshaft sprocket with the camshaft hub. Use a 3/8 breaker bar to rotate the camshaft until the holes in the hub align with those in the sprocket. And install the bolts. Install the left camshaft sprocket in the same way. Keep in mind that the holes in both sprockets will only line up one way with the holes in the hubs. Once the sprockets have been installed, you may need to rotate the engine slightly to take up slack in the timing chain. It's important not to skip over the next step in chain installation, arming the chain tensioner. Failure to arm the tensioner will cause serious problems once the engine is started. To arm the tensioner, use a flat-bladed screwdriver to pry the tensioner arm towards the tensioner. This releases the ratchet mechanism and provides tension until the engine develops oil pressure. After arming the tensioner, rotate the engine 1 revolution clockwise so that the tensioner can extend fully. When reassembling the rest of the front, don't forget to install the camshaft position sensor. Also, keep in mind that the plated links and timing marks are not designed to line up on every rotation of the engine. So you should not rotate the engine 2 revolutions and expect the marks to align. Also, after you install the chain, it's normal for the engine to make some noise for 5 to 10 seconds at startup. Before we move on to other features of the 2.7-liter engine, let's check your knowledge of chain installation with a review question. The 2 plated links on the primary chain are positioned near the timing mark on the A. crankshaft sprocket, B. left camshaft sprocket, C. right camshaft sprocket, or D. water pump sprocket. The correct answer is B. The mark on the left camshaft sprocket is positioned between the 2 plated links. Like the lower and front end, the upper end of the 2.7-liter engine has a number of special design and service features. When servicing rocker arms, keep in mind that they are unique to the 2.7-liter engine and can be identified by the presence of the oil squirt hole. You can remove the rocker arms from the cylinder head without removing the camshafts, using special tools 8215 and 8216. You can remove the lash adjuster and replace it separately if it is damaged. If you plan to reinstall the lash adjuster, be sure to store it in an upright position so that the adjuster doesn't become filled with air. It is possible to install the rocker arms backwards, so during installation, take care to orient the rocker arm correctly. If you watched October's program, you know that the 2.7's camshafts are different from cams machined from a solid piece of stock. The cams are made of tubular steel with machined bearing journals, but with pressed-on lobes, secondary timing sprockets, and thrust flanges. The 4 cams on the 2.7-liter engine are not interchangeable. Each cam has 5 bearing caps, which are marked to identify their location. The exhaust and intake cams, secondary chain, and secondary tensioner are removed as a unit. Be sure to see the service manual for proper removal and installation procedures. The camshafts must be removed to access the cylinder head bolts. And don't overlook the 3 bolts in the timing chain cavity. They must also be removed before removing the head. The cylinder head gaskets on the 2.7-liter engine are multi-layer steel construction. They include an oil restrictor hole which controls oil flow to the head. In October's Mastertech, we told you about the 2.7-liter engine's upper and lower intake manifolds, which are made of a composite material. The gaskets for the upper and lower intake are reusable. But be sure to inspect any used gasket for deformation or damage before reusing it. Next, we're going to move on to the features of the 3.2 and 3.5-liter engines, right after this review question. True or false? The camshafts in the 2.7-liter engine must be removed to remove the cylinder head. The answer is true. You do need to remove the camshaft to access the head bolts. And don't forget the 3 head bolts in the timing chain cavity. Earlier in the program, we discussed some of the special features on the lower end of the 3.2 and 3.5-liter engines, such as the 4 spots where you need to use sealant, and the fact that the number 2 main bearing is the thrust bearing. Now let's look at some of the other features on the lower end of these engines. As on the 2.7-liter engine, you need to use special tool 8225 to align the rear main oil seal retainer. However, on the 3.2 and 3.5-liter engines, the tool is flipped because the retainer contains part of the oil pan gasket. As a result, the retainer must be oriented differently than on the 2.7-liter engine. The piston and connecting rod assemblies on the 3.2 and 3.5-liter engines are a different design than the assemblies used on the 2.7-liter engine. The connecting rods use machined caps, and the cap bolts are installed from the top. Even though the piston pin is retained by locking rings, the piston and connecting rod are replaced as an assembly. You'll notice slight recesses cut into the tops of pistons on the 3.2 and 3.5-liter engines. These recesses do not provide valve-to-piston clearance in case a timing belt breaks. They are only there to provide clearance in case the timing belt is off by no more than 2 teeth. Like the 2.7-liter engine pistons, the pistons in the 3.2 and 3.5 have an arrow that points towards the front of the engine. And as on the 2.7 pistons, the squirt holes must be facing the major thrust side of the block. You can use the left-hand rule described earlier when we covered the 2.7-liter engine to determine the major thrust side. We need to discuss one more feature of the lower end of the 3.2 and 3.5-liter engines, the engine oil cooler. On both engines, an outlet line from the block and an inlet line back to the pan route oil through an engine oil cooler in the radiator tank. The oil cooler is not used with the 2.7-liter engine. Earlier in the program, we mentioned that you can use special tool 8191 to hold the crankshaft damper on the 2.7-liter engine. You can use the same tool to remove the damper on 3.2 and 3.5-liter engines. The valve timing and water pump drive system on the aluminum block 3.2 and 3.5 liter engines is similar to that used on the previous cast iron block 3.5 liter engine. The system uses a single belt to drive the water pump and the single overhead camshafts. As we said before, unlike the previous 3.5 liter engine, the new engines are not freewheeling, and if the crank to cam timing is off by more than 2 teeth, damage will occur. The timing procedure is similar to that used on the previous 3.5 liter engine. One thing to keep in mind when servicing the timing belt, however, is that it is not the same length as the one used on the previous 3.5 liter engine. Another thing to keep in mind is that if you do remove the belt tensioner, be sure to store the tensioner in an upright position so that air does not enter it. The water pump on the 3.2 and 3.5 liter engines was introduced in 1997 as a running change on the previous 3.5 liter engine. The pump uses a 6-bolt mounting instead of the previous 3 bolts and features improved sealing. Now let's move on to some of the features on the upper end of the 3.2 and 3.5 liter engines. The single overhead camshafts on the 3.2 and 3.5 liter engines have 3 cam lobes per cylinder. 2 lobes are for intake valves. The third lobe actuates both exhaust valves by means of a Y-shaped rocker arm. Although the camshafts on the 3.2 and 3.5 liter engines look the same, they're not. You can identify 3.2 liter camshafts by the groove machined into the cam near the nose. Unlike those on 2.7 liter engines, lash adjusters on the 3.2 and 3.5 liter engines must be serviced with the rocker arm. However, as with the 2.7 rocker arms, if you plan to reinstall the rockers on the 3.2 and 3.5 liter engines, be sure to keep them upright so that air does not enter them. As you saw in the October Mastertech program, the 3.2 and 3.5 liter engines use a composite upper intake and aluminum lower intake manifold. The PCM operates the manifold tuning valve at the front of the upper intake and the short runner valves in the center of the upper intake to maximize performance. Next, we're going to look at a procedure you need to be familiar with when refilling the cooling system. But first, try this review question. You can identify 3.2 liter engine camshafts from those used on the 3.5 liter engine by A, the length of the cams, B, the number of bearing journals, C, a stamping on the 3.5 cam, or D, a groove near the nose of the 3.2 cam. The answer is D. The 3.2 liter engine's cam has an identifying groove near the nose. When filling the cooling systems on the Concorde, Intrepid, LHS, or 300M, to avoid trapping air in the cooling system, be sure to use the procedure and special tools specified in the service manual. First, make sure the radiator drain is closed. Then attach one end of a 1/4-inch hose to the bleed valve on the engine. On the 3.2 and 3.5 liter engines, the bleed valve is located on the lower intake manifold. On the 2.7 liter engine, the bleed valve is located on the water outlet connector on the front of the engine. Route the hose away from the components on the front of the engine and place the other end in a coolant container. Next, open up the bleed valve on the engine. At this point, attach the filling aid funnel, special tool 8195, to the pressure recovery bottle filler neck. Use the clip attached to the funnel to pinch off the hose between the 2 chambers of the coolant bottle. Now pour a 50-50 mixture of distilled water and Mopar 5-year 100,000-mile antifreeze coolant into the large side of the funnel. The smaller side allows air to escape. It's important to use only 5-year 100,000-mile coolant in the system. Mopar's 5-year coolant can be identified by its orange color. The use of other coolant types will not provide the additives that permit extended change intervals. Continue filling the cooling system until a steady stream of coolant flows from the bleed valve hose. Then close the bleed valve and continue filling the system to the top of the funnel. Remove the clip from the overflow hose and allow the coolant in the funnel to flow into the overflow chamber. Remove the filling aid funnel. Install the cap on the pressure recovery bottle and remove the hose from the bleed valve. Keep in mind that it's normal for the coolant level in the pressure chamber to drop as any air in the engine is pushed into the bottle. Also keep in mind that once any air is out of the system and the cooling system has had the chance to replace it with coolant, the coolant will not flow into the recovery chamber unless the engine overheats. Well, that about does it for our look at the 2.7, 3.2, and 3.5 liter engines. As we said at the beginning of the program, the engines are not really difficult to work on if you use the correct procedures and the right tools. Now stay tuned for information about the results of the Mastertech survey. As you recall, in May of this year, we sent out a Mastertech user survey along with the monthly Mastertech kits. Well, the results are in. We feel that the information we've gathered gives us a better idea of where we stand with you, the Mastertech audience. First of all, we'd like to thank those of you who took the time to complete the survey and return it to us. In fact, over 6,700 responses came in, and overall, most of you appear to be quite satisfied with the Mastertech program. As you know, Mastertech is geared toward individuals who work in the service field, including service technicians, managers, and advisors. Of our responses, 71% were from service technicians, while service managers made up 10%. We try to gear each monthly release to as large an audience as possible, so everyone can benefit. For this reason, we included a question concerning technician skill categories. As you can see, of those who responded, 77% listed brake systems as one of their specialties. 67% listed one of their specialties as engine repair. We were curious as to how many of you actually watch the Mastertech videos. Interestingly, only 63% of our respondents watch the videos on a monthly basis. We're happy to say that overall, Mastertech rates fairly high as a useful source of technical information. 99% say that the information contained in the videos is useful to technicians, and 98% would recommend the program to not only new but experienced service personnel. Because Mastertech is used as a training aid, other materials were ranked higher as a primary reference for day-to-day repairs. 31% refer first to shop manuals or the MDS, DRB, and Copilot, and 1% use the videos as their primary reference source in solving service problems. One thing we determined is that technicians who watch more Mastertech programs in a year report greater benefits from participating in the program. Mastertech videos seem to have the most positive influence in shops that require Mastertech participation and permit technicians to watch when they choose. Although Mastertech is rated favorably by those of you who use it most frequently, we'll continue to concern ourselves with the quality of our program and seeing to it that Mastertech meets your needs. So in the future, we'll be asking you for your opinions on what you would like to see covered in upcoming Mastertech programs. Starting in January of 1998, you'll find a comment card included in the monthly Tech News. With your input, we can get an idea of what concerns are important to you as a technician. Well, that brings another year of Mastertech to a close. We hope you've enjoyed this year's 50th anniversary celebration. You've been a great audience, and we look forward to spending the next 50 years of Mastertech with you.